the inference chip is making decisions, basically reacting to input.
Mm-hmm.
It's all reaction. There's not a lot of planning as far as we know. There's some planning that they're training in, but it's really just sort of reacting to what it sees.
Mm-hmm.
And the training compute trains the chip how to react.
Mm-hmm.
So and the same thing when you're using ChatGPT or Claude or Grok, when you ask it a question, your reaction is coming from inference.
Mm-hmm.
The training like retrains the inference. So I hope that's helpful. I hope that's not too confusing. And
Mm-hmm.
I had other people tell me that that was helpful.
Hello, everyone. Welcome to Nextbigfuture. I'm glad to have Elon Musk's buddy, Warren Redlich, joining me. he's answering your email.
We're this close.
Yeah, that's right. So we're going to talk today about AI inference. What's going to happen with AI5 and all this business. I prepared various analysis, and of course, Warren will chime in as I go over it, and then we'll also have deep discussion afterwards, and we'll have all kinds of discussions about, is there some kind of monopoly, all kinds of important issus around this. So first let me just lay the groundwork.
First mover advantage.
First mover advantage. That's right. So I'll go over some of my groundwork type stuff related to kind of get everyone on the same page of what we're discussing here. So Tesla distributed AI inference. So basically, AI inference is getting the answers for AI. AI training is making the models to give you the answers. I have a cost revenue analysis. I have information from Altimeter Capital, the $10 million fund headed by Bill Gerstner and
Brad Gerstner.
Brad Gerstner and Bill Gurley. Yeah.
Which one? Brad Gerstner.
Brad Gerstner and Bill Gurley. That's right. The BG2, right? And they have their $10 million fund has various metrics comparing AI to Google. NVIDIA gave information about inference revenue in their quarterly talk, and I'll give a ballpark of Tesla AI5. So first, the background for people who are not as familiar with all this AI stuff is that AI training, you feed in a large amount of data, terabytes, hundreds of terabytes, thousand terabytes of data into your learning algorithm, and then you produce a model that makes predictions. It learns to recognize patterns in the data, and then you generalize the data to make new against new and unseen data that you can apply to other things beyond what you started training from. AI inference is you apply the trained model to new data to make predictions or decisions. It uses the patterns to learn during training to make predictions about the data, and it makes predictions or decisions in real time, or it can also do other work like for self-driving cars stuff.
I just did this on my channel. I was doing a video and I got a lot of feedback that people liked how I explained training versus inference.
Okay.
And so you start by thinking about the Tesla car, right? In the car is the inference chip, and the supercomputer data center has the training hardware and software. And so what happens is the training stuff, the car's driving along and photons are coming in the cameras, lights coming in the cameras, the car responds to the light. There's some other inputs, like you've got navigation directions telling it to go to this place, right? And so the car reacts to what comes in the cameras. And it's a little bit like muscle memory. Like if you're playing tennis and somebody hits the ball to you and you hit the ball back, you're not necessarily thinking that much about it. A lot of what we do in life, and you're driving the car down the road yourself, some of it is planning, but a lot of what we do when we're driving is just reacting, the way we've programmed ourselves or trained ourselves to react. And some things are muscle memory and some things are just sort of reaction, instant reaction. And I would say, in some sense, when we go to sleep at night, and when we dream, or when our brains are processing the data that we've accumulated over the day, maybe there's some level of training compute in our brains that retrains us on how to do things next time. I played a lot of basketball, and I'm working on my shot, and I'm working on my shot. You get better if you work on your shot. So, whatever sports you play, you can kind of see it in that. When you drive a car, when you start driving a car, you're not very good. After 10,000 miles, you're a lot better. After 100,000 miles, you're a lot better. And it's the experience that trains you to react better in circumstances. So in the car's reacting to photons. With Optimus, it's different, because Optimus you have the inference chips in Optimus, and it's probably going to be AI5 chip. I posted about that, and Elon said yes. So Optimus ultimately is going to have the AI5 chip, which is 2 generations after the hardware 3 chip that's in my Model 3 and my Model X. I think my Model X has whatever.
Yep.
Current cars have hardware 4. The next generation is going to have AI5, and that's about 18 months away.
Yep.
So, currently they're probably using hardware 4 in Optimus, but Optimus has to do a lot more than the car. The car just navigates space, and it navigates a restricted space. The bot has to navigate a more complicated space, although at lower speeds, and it has to manipulate objects, which is another level up. So you've got the inference chip is making decisions, basically reacting to input. It's all reaction. There's not a lot of planning as far as we know. There's some planning that they're training in, but it's really just sort of reacting to what it sees. And the training compute trains the chip how to react. So and the same thing when you're using ChatGPT or Claude or Grok, when you ask it a question, your reaction is coming from inference. The training like retrains the inference. So I hope that's helpful. I hope that's not too confusing. And I had other people tell me that was helpful.
Okay. Yeah. So that basically is, more getting it ingrained, however it is based on reaction time of the model and computer, so that it's ready to do what it was been trained upon. And it's going across a broad range of all the internet's data, all the video stuff. So it's a very broader than most people. But so I think that is a good way to explain it. So let me go again with my presentation thing
sorry.
here. No worries. I think, the more we can, so I think the better background that we give to people so they can understand what's going on, the better, because there's a lot of assumed knowledge about all this AI stuff that I think we need to get people familiar with what's going on. And so then whatever you're trained on is hopefully going to be valuable and people pay for it. And that's the question that we'll have to work into. So some of the current descriptions about making money: subscription to customer service chatbot, which looks like that's going away. Looks like the Meta Facebook giving away open source Llama 3, and then making money off of people being on Facebook and Instagram and making advertising dollars seems to be that. So that you have to make money other ways than paying a monthly subscription. That monthly subscription thing is going away. License the model, which Tesla may do to other companies, whether you make the money from there or not. And OpenAI, ChatGPT have some licensing to Microsoft or their ownership, and then or you can have smaller companies pay larger fees at a corporate level where they use their own data, get insights from the data, make money, more data, and then sell the new insightful data. Use AI to solve specific problems like in medical diagnosis or for driving the car. And this is, of course, something that we'll dive into more about. This is just a kind of an overview of making money with it. So where is Tesla and Elon with AI? Tesla sold about $3 to $4 billion worth of full self-driving software over several years. Tesla sold billions to owners getting autopilot, enhanced autopilot. Tesla is developing full self-driving up to version 12.3.6 currently, but 12.4.1 is in limited release, maybe 12.4.2. And then we have FSD 12.5 and 12.6 probably in testing. And then August 8th, there will be the big robotaxi announcement. Don't know what's going to be. People presume it's going to be at least a car, whether it be partnership or other thing, we don't know. And then as Warren just said, no, hardware 3 is the hardware computer and cameras in most Teslas. There is hardware 4 in quite a number of newer vehicles in the last year or two, but hardware 4 is not fully utilized by the software. And then hardware 5, renamed AI5, was just announced, which
just to be clear, I think hardware 4 will probably outnumber hardware 3 by the end of next year.
Okay.
And then AI5 comes the end of next year, and I think AI5 proliferates really fast.
Right.
My gut is Elon. They're doing, some volume. I think they're doing a lot of hardware 4 in the data center in Texas, but But I think my gut hunch is Elon's plan is to manufacture a massive volume of the AI5 chip.
Right. And I'm going to be discussing some bit about my views on AI5 in terms of how it scales with this whole thing. And we'll go over that spreadsheet, as well as how I feel Hardware 5 in context with these other chips that are out there competing for the inference market. NVIDIA Grok, the other Grok, the one that's making chips funded by Chamath.
GROQ.
GROQ, right. So here is a chart from Altimeter Capital, and this is a few months old, but they were basically saying on the left is informational searches, Google searches, costing 0.3 cents and then making 4.5 cents. And then previously, large language model-based searches at 3 to 30 cents cost, and then in the range of 3 cents per search is how much they're making money. So they're not profitable, or they were like at profit, where if it was at the lowest cost of 3 cents to 3 cents, and the Google cost per query was they're making about 15 times more than what they were costing. And this is, from a big VC who has insider knowledge about what these models are. But this thing on the right, the large language model-based searches, that has supposedly changed based upon what NVIDIA said. Also, in terms of search queries per day, they're expecting that there already has been certain level of replacement of people doing queries against all these models, ChatGPT, Gemini, Anthropic's Claude, something like that. And this is going up because Meta is putting like Llama onto their main pages to get more searches, and then Microsoft putting onto their products all these things. So they're keeping people on their products and not going to Google to do the searches because they're using the AI systems. And then a dotted line projection of some kind of crossover at some point, which they weren't expecting until later, but we don't know.
Well, isn't it when you had this thing about the cost per query?
Yeah.
And my guess would be that that's falling fast.
Right. So I have updated information about that. So NVIDIA on their conference call of like the last presentation that Jensen made said that the H200 chip after H100 before the B200 was tuned quite a bit for inference, and if you buy that hardware and presumably also the data center costs and the energy, which I think triples the cost. So you spend $40,000 for H200 chip, you have to have $40,000 for a data center, $40,000 probably per year for the energy. So you have $120,000 cost. But they say you can make 7 times revenue versus your cost over 4 years, which if we go 7 times 120,000, I think that's 840,000 over 4 years. They did not give details on, full breakdown on some of these costing things. So 7 times revenue, I'm presuming is an all-in cost. But they did say in a separate NVIDIA blog post that the assumption was it would be 60 cents per 1,000 tokens that were used for these questions. So packing that all in, I did some reverse engineering on some of these numbers. So here's some of the details. A single dollar invested into their chips, $7 in just 4 years running the Llama 3 7B model. So they're using an open source meta model onto their H200 servers, assumes Llama 3 is used for it, and that you're getting 60 cents per 1,000 tokens, and with a throughput of 24,000 tokens per second. Which, when I ran the numbers on that, it didn't look like they were maximizing, saying you get so many queries per second. It seemed to be about a 3-cent query every 7 seconds, again, using the number from Altimeter Capital, and $1 every 4 minutes, and then $575 per day. It seems to be the rough numbers so I went from both sides, went from trying to build up from the cost up and also from the revenue back to get some numbers like this. Because if you just ran and saying you're going full out or even at 10% capacity for your 24,000 tokens per second that the thing is capable of, you would make way more money than what they're saying here. So they have some kind of like factoring in on that. The Grok chip is half the cost, $20,000, but is only like 10% of the performance or 5% of the performance. So it's increasing. But if the H200 does that 24,000 tokens per second, then it's a huge value. So then that Grok would also be, like the Altimeter was saying, not quite at profitability. So, but presumably, and go to AI5 here, presumably Tesla will, going a year away, would be as profitable as the NVIDIA chips are now on that, but they'll be using presumably XAI AI instead of the Meta open source. So if it's $2,000 per chip, because currently I think it's about $2,000 for the hardware, I'm presuming they go for a slightly more costly chip. The distributed energy and infrastructure means that they don't have to build the data center because it's in the car. And of course, they already paid for it. Go
Let me
ahead.
just pause you for a second. You made a
Sure.
big leap here to
Yeah.
AI5 being used not for real world AI,
Yeah.
but maybe be using it for large language models or queries or as a chatbot service. And
Right.
I'm not convinced that that's Elon's target.
Okay.
I mean, I think the primary target of AI5 is solving Optimus
Right.
and solving large scale inference compute. And then the question is, what's the large scale inference compute for? The first use case I see for large scale inference compute is testing your trained model in simulation.
Mm-hmm.
And I think that the demand for Optimus and I think that if you're optimistic like I am about the cars, we're going to see FSD solved. Not completely solved. They'll continue to improve it, but we're going to see FSD solved within a year or two. Maybe sooner, but to the point where it's safer than human within a year or two, if possibly sooner, maybe later, but it's not that far away. And once it's solved, once it's safer than human, then you're going to have incremental gains. It'll get better, it'll get better, it'll get better, but that's not the big as big as robotaxi is, that's not the big game changer. The
Mm-hmm.
big game changer is Optimus, and you might have 100 million cars, but you might have 2 billion bots
Mm-hmm.
in the long run.
Right.
Maybe you'll have more than 100 million cars in the long run, but 100 million is a lot.
Mm-hmm.
But bots, like, you could see a billion, 2 billion bots, and then the I think there's an endless training loop
Mm-hmm.
to training the bot, because the variety of scenarios in the real world that the bot will encounter are so much more diverse.
Mm-hmm.
Even as diverse as driving is, the scenarios that the bot will encounter are so much more diverse that I think that I think there's two things. One, the value of real world AI compute is much higher
Mm-hmm.
than chatbots, and the demand, the volume of demand is maybe infinite,
Mm-hmm.
or effectively infinite.
Right.
So sorry, I went off on a rant again.
No, no, no. That's I want to push back because just because I put it down into PowerPoint doesn't mean it's right. You know, I'm just but my idea was to take the building blocks of the NVIDIA information and the alternative information and then process it forward into like what Elon said, he wanted to do the inference for 70% of the capacity, like 30% spending on the driving and then 70% spending on inference, making money, extra money, incremental for the user, owner of the car, incremental for Tesla. Is that, you're already making something presumably profitable with FSD or with whatever, and the hardware is already there. And then in the time that you're not using your car, you're getting this extra value. But if in terms of the demand, it could be that Tesla's also bringing their own demand because SpaceX does that, where they make 120 launches or 150 launches this year, that 130 of those are to launch Starlink.
Yeah.
That they're doing their own thing in order to bring the values, which goes to that chicken and the egg thing. Like everyone else has to answer how much um, inference revenue do people need? Is it only replacing the $80 billion of Google search, or is it per year and growing, 20%, whatever per year? Is it only doing that, or is it, there's more to it, so then you're doing more than just a Google search, so then a double or triple? But then after that point, you say that maybe the demand's not infinite. So then how much do you put into office software and to office work, AI enhancement, inference?
Yeah,
So
I
that,
just feel like the large the LLMs,
mhm,
the Chat GPTs and Claude Sonnets and Grok and Meta Llama, they sort of become commodities. And the thing is, Google has a massive lead in search,
mhm,
and so Google corners this market and is able to make more money out of it because it controls the market.
mhm,
If nobody control if the large language model space is competitive, you might get a lot more queries. You might actually eat a lot into Google's share of search in effect,
mhm,
but you might not make any money at it because the price falls to zero. And my gut hunch is that what I'm seeing from ChatGPT, from OpenAI, and I think I'm seeing it from a couple others, is the money to be made is using your model a little bit like, I guess, what Palantir does, going into large companies and saying, hey, let's see if we can use your data to train
mhm,
our model to give better answers internal to your company, which
mhm,
is valuable, but I don't think it's as valuable. That's B2B is valuable, but I don't know if that market is as valuable as the B2C market.
mhm.
Um, I don't know. I'm not saying it isn't. I just like,
Yeah.
well, what's the value there? So I think there's just this open question of what's the value of large language models. And maybe they come in, you have diffusion models and trans whatever, there's other models. So maybe somebody comes up. I think one of the questions that's out there is what other use cases are coming for AI that we don't see yet?
Mhm,
So we got real world AI, we got operating cars, operating robots, okay. We've got answering questions and responding to prompts, okay. Are there other use cases? We also have like write some code for me,
mhm,
right? Which is like it's hard for me to relate to that AI Copilot or whatever.
mhm,
Um, how many other use cases are there that we haven't thought of? And my guess is that that's Sam Altman's job.
mhm.
He's thinking about use cases. He's not thinking about making the models better or safer. He's thinking, how do we market this in a way that we don't become commoditized? And providing the consulting service to a Fortune 500 company or a Fortune 1000 company of we can end up making your company run better because we can access your data and give everyone in your company better answers.
Mhm.
Like I don't get that. Like same thing Palantir does. I don't really understand it, but I see the value there potentially. But I really struggle. Like, are we going to see other use cases that we don't see coming yet?
Right. So I think so. So the what the VCs like Altimeter are saying, from that chart was that Google's search stuff basically gets displaced. That they, Chamath, Brad Gerstner, Bill Gurley, they're all saying that um, the envisioned experience with a large language model, which we're kind of seeing now, is you ask it the question, the prompt, you get the answer, and the good detailed answer can be a very long answer. And the Google search is giving you, pages of
Links.
links, and then
Yeah.
you go to the page, and they're saying that that's inferior. So they feel that that's going to be replaced.
Yeah,
Google,
I use Chat GPT, Claude, and Grok more than I use Google. I used to use Google
right,
all the time,
right,
and I have changed. And I'm an early adopter.
right,
I think that and you're probably doing the same thing. So early
right.
adopters are doing this now. It's going to spread fast, and I don't
Mhm.
know. I mean, I saw somebody explaining how Google survives. I wasn't very persuaded.
Right, right. So their Gemini must keep pace. And you talked about all of them being the same. So, when we look at GPT-4 came out, a year ago, and everyone seems to have GPT-4 class models. Like in the rankings, it's close, right?
Well,
So,
Grok isn't there. XAI's Grok is not there yet.
right,
Claude is there, and I think Llama is there.
right, right.
Gemini's
So,
not. I don't think Gemini's there. I think Gemini's crap.
right, right. But several companies have gotten to GPT-4. They're in the ballpark of it. And yes, like Gemini made me inferior, Grok made me inferior, but it's the gap for light usage is not, like you will get a decent answer for a common trivial type question, right?
I think
If you
you can
go
get better
deeper,
answers. I think you get better answers from LLMs than you get from Google.
Right, right. So, but people have roughly caught up in a year. It took a year and then I think they're keeping pace. So then, that goes to my table where I have, later on my thing of um, as you just increase compute, data, your model, stuff like that, it's tough for anyone to maintain a advantage other than if you have proprietary data that other people can't get, which would be an issue of like when you have AI making music or art, basically, as described in a video by uh, this music YouTuber, saying that basically AI is just a super advanced plagiarism machine. That basically it's just taking all the music that people have made and then giving you that capability. So then it goes to but then if you have what's the open data, unless you generate your own, that goes to real world data, getting recordings of voices, recording of people talking, of people doing stuff, which goes to the real world aspect of it, to learn from classes and that kind of stuff. That is one, how they get better, but then it, you'd have to have your army of 2 billion bots helping you generate and gather the information to learn better in order to have that differentiation. But then in this initial phase, where just what's digitized, and I take what's digitized and use it, it doesn't look like anyone's establishing a superiority, right? That
Right.
I'm making GPT-5 better. We'll see when GPT-5 drops. But if it's taking longer and they expect it to be better, right? But have you kept that advantage? Because it's taking you a while, and other people have caught up. So
Yeah, I think that we should also be prepared for these guys are not just making larger models.
yeah,
There are super smart, I don't want to say super intelligent because that gives you the wrong impression, but there are
yeah,
some very, very smart people working in these companies.
yeah,
And they're probably working on, I like the terms Elon once referred to, improving FSD as stacked log curves. That
yeah,
you get some improvement, but then it starts to flatten, and then you come up with a new way of doing things, and you get a new log curve that goes on top.
yeah,
And they're not just working on improving the models, which is probably hitting some sort of asymptote.
yeah,
They're also working on, okay, how do we revolutionize the model
yeah.
to add another log curve on top? And um, that's where the real innovation is, and that's why I think XAI has a real advantage,
Hmm.
because if you're tied in with Microsoft and Google and Facebook, then you've got this sort of corporate culture that slows you down.
Hmm.
That's one of the things that Elon gets is, we want full speed ahead,
Yeah,
don't stop for anything, break shit and fix it later
yeah.
mentality. That's going to lead to, I think, longer term, I think they're going to solve a lot of AI stuff better, especially with their access to real world AI.
Hmm.
But I look at, I think Jan LeCun is pretty smart. I mean, I think there's pretty smart people at every company, but
Yeah.
Google, they're very like, it's really surprising Google's doing so poorly with Gemini.
Hmm.
I think that's probably a result of the corporate control that that
Hmm.
it's not, they're not innovating in the same way because they've got too much political correctness or whatever going on. What do you think? Why is Google behind? I don't know if you care about this, but why is Gemini so far behind?
I think it's that their corporate culture got soft.
Yeah.
I think that it's being here in the Valley and stuff like that. People who worked at Google, they're just you know they're sucking up the Google ad dollars from the AdSense and stuff like that. So they haven't been able to launch any major product. They bought YouTube. They got Android again from another company, and they developed so Android software and YouTube were things that they developed new from the initial Google search and Google Ads, right? But all that other stuff is only like 20% or whatever of the company, and YouTube had to come from outside, right? And they did develop it. Android, they did not. Yes, it's on a certain number of phones, and they partnered with it and with other companies, cell phone companies, and it became a major success that way. But they don't make that much money from it. right? So in terms of launching new innovation, they haven't done it really since the first thing, other than two decent acquisitions and not screwing those two things up. And and then so then the rest of it is that the people within, just like like Elon fired 80% of Twitter and stuff like that, there's a lot of people who don't have to, they're smart people. I know people who work at Google, they're smart people and stuff like that, but they don't have to, like their life dependent upon it, get something
The
to,
professional managerial class.
right, right. And so they don't, and they often they like do something and then they, do a side business hustle thing, training and leveraging the brand of Google and doing that kind of stuff, right? So they can do other things from that capability, but they don't have to like, it's not like Google saying you must launch a new product or something like that, right? There's not
Right.
that culture with, and they hadn't been that for a while. And they had the founders retired, and then they came back a year or two ago when they saw, holy crap, OpenAI is a true threat to what we did. So now we come back in, but they had basically kicked back onto some beach someplace, and then they had to come back in, right? So it's kind of like Rocky 3, right? Where first two times he's from fighting and stuff like that, and then the third one he's gotten soft, and then he has to go retrain and find it. So they have to redo that because they basically like they had the lead in AI and they lost it to OpenAI just because they didn't double down on all the spending and the chips and all that kind of stuff because they weren't hungry enough. And also they weren't willing to push it. Didn't want to sacrifice the search with this is getting us
If you
weird
don't
answers.
cannibalize yourself, someone else will. This is the perfect example of it.
Right, right. So I think that those are the things. It's basically they got soft, they weren't willing to cannibalize. Now they're hungry, but they have to. I think also Meta had lost their stuff, focusing on the metaverse and everything like that. But Zuckerberg was um, still there, and he's still willing to make quick decisions to
Yeah, he
force things
pivoted.
back. And he pivoted pretty hard. Although I still think he's doing metaverse stuff, which I don't think is going to work. But he's AI with metaverse. He must see something that I don't see. But he's still able to get Meta back in the game quicker
Yeah.
than the Google guys have done. I think Google guys could still, come back and surprise because they have DeepMind, so they could do stuff in the next year. But it's lighting the fire underneath the teams to go all out. They did launch a code red, but the code red got them to
Well,
Gemini,
and
which he,
there's the political correctness problem that if the AI tells the truth and the
yes,
truth goes against the politically correct story of the day,
right,
then they have to fix it when XAI is like, no, we don't have to fix that.
right,
They have constraints related to political correctness, DEI, all this other stuff that I think interferes with success.
right,
And more than other stuff that's works more standard corporate bureaucracy stuff where
mm,
Elon cuts out the fat. So I'm guessing that we're going to see Grok 2.0 by the end of the year, and it's going to be at least as good as
mm,
ChatGPT 4.
yep,
And then I sort of get to this point where I just want to ask you about this. I actually think ChatGPT 4.0 got worse than ChatGPT 4. That's another conversation. But you know, is have we reached the an asymptote? Like, is it really going to get better? I've been using ChatGPT as a sounding board for topics like strength training, nutrition, life planning, and stuff like that. And I feel like it got soft. Like it
hmm
used to push back. It used to argue with me more.
hmm
And now it's like it just sort of says, yeah, that sounds good to like everything I ask it. I'm
right,
like, well, no. You used to give me like some feedback. You used to challenge me, and I don't know if I got smarter, seems
hmm
unlikely,
yeah,
or if it got softer.
right,
And I actually think Claude was better about. I've only been playing with Claude a little bit. I think Claude was a little better, and I'm expecting that. And I think Grok is more like a party trick right now. I think Grok will get better in the next version.
hmm
I don't use Llama. Do you use Llama at all?
no, not use llama, yeah. So I would say that the testing aspect of things, my understanding is Anthropic uses more automated AI testing the AI kind of thing. right? So they have more automated testing about which one lets them move faster and let them be more thorough. So the fact that they have an Google and Meta may have an army of people that help fine tune, which was an OpenAI fine tuning. So that goes to the corporate culture, the DEI stuff. Like if your people are all with that, then you're going to end up with the bias model that way. But then they may overdo that in order to avoid whatever corporate pitfalls of answers they don't want to have out there,
Right.
which would then give you us answers that we don't necessarily want. It needs to be our profile. It matches just like for driving, it matches our aggressive or less aggressive profile. You need to have it match your profile. So it's tough to do with something so big because basically it's the whole internet to have all the hard edges polished off. If you spend your time polishing off hard edges instead of like getting the thing better, that's a problem. So in terms of like reaching asymptote, a leveling off, um, everyone who's still in it, who seems to be looking at stuff behind the screens that we don't see or next generation models, seem to be saying it keeps getting better. What was it? Karpathy was talking about the meta models and and also the other language models, how they're all undertrained by like 1,000 times. That basically there's something called the chinchilla point where you do all this compute and you train, you keep working it, and the model gets better. And also you can keep it smaller, right? And that Meta pushed that further, but it was still, say 75 times more trained than some other models, but it was still undertrained relative to where theoretically it could and should be, right? So that seems to be that if you just got more compute, you could get to 1,000 times more trained, and then you would get a better result. That's what the formulas, that's what the experts like Karpathy seem to be saying, right? So,
And,
um,
and then and then they're facing limits on how big they can build their AI data centers,
right.
which makes it hard to add enough compute to do what you want to do.
Right. So then it's who can build more energy, who can build more stuff. So it's a infrastructure, like I must build a Tower of Babel, I must have more bricks and stuff in order to achieve this thing. Um, Going to what some other people are saying in terms of like how high. Ilya Sutskever, who was the chief scientist at OpenAI, who left, tried to fire Sam Altman, and then ended up leaving, even though they kind of made up. He set up his new company, Superintelligence, Superintelligence, and
SSI.
SSI, and he says that he has an expert who created a lot of these advances, says that he can get to superintelligence beyond human. So there's, of course, he would say that because he's getting billions of dollars to build it, but I think that he's honest, that believe him, that he's sincere. Just like Elon says that we can get AGI next year. So I think that whatever asymptote we're looking at is a temporary thing, and that whether it's a year or two, they could all be off in timing, but that there is more there to achieve. That there's um, gaps in what we have that are clearly fixable, that we can get to it. Also, an interesting thing was by Dr. Alan Thompson. He has a AI consulting practice and a website, lifearchitect.ai, and he gives a monthly memo on it. In a recorded thing, he recorded a woman who is like 25 working in high up within Anthropic and making Claude. And she's seeing the next version of that. And she says that she wants the recording of hers. In 3 years, she wants to retire. She feels that superintelligence is going to replace all our jobs. And she's talking about how, we need to exercise and stay happy and all this kind of stuff. Basically, she sounds shook by how good she sees this stuff being. So whether she's just a fragile person, I don't know, but it's basically that many people who, we only have pieces of information seem to be saying that uh, superintelligence is still there, that improvements are still there. It has to be actually get there, to make the work. But it's interesting that there could be more to it. If you have more comments on that, we can, or I can pop back and finish up my quick presentation
Oh,
with
go ahead.
this. Okay.
I have a lot in my head, but let me just you go ahead. I'll get focused.
Okay. Okay. So again, this is my estimation of it that I think that it gets to 200 teraflops based on the H200 being 4 petaflops, B200 being that the hardware for supposedly a trillion operations, but not floating operations, but that AI5 is supposed to be 10 times more, which would be 1,000 trillion operations, which would be a petaflop,
Exaflop.
a
Oh, is that a
petaflop,
petaflop or an
a
exaflop?
petaflop. It's a petaflop of it, which would be one quarter of a H200 and 5% of a B200, but it would be in line with if it's $2,000 versus $40,000, it'd be in line with a B200 uh, for if it's a petaflop.
See, see, when you say $2,000 a chip for AI5,
Yeah.
I think Elon's going for 500. I think
Okay.
that's why I said he's going to manufacture them in massive volume.
Right.
I think he thinks he can get there and get the because it's not an H200.
Yeah.
But what did he say? I think he said they're going to use about 800 watts peak.
Right.
And there was this number like if you have 100 million Teslas with these or 100 million Teslas and bots with AI5 hardware,
Mhm.
you have like 100 gigawatts of compute. Like you're talking about teraflops. I don't think that's the relevant measure. I think it's the gigawatts of compute because we know that a typical AI data center now, the large ones are 100 megawatts.
Mhm.
So if you get to 100 gigawatts of compute on your, car when when you add up all the cars that are sitting there not doing anything,
Mhm.
you got 1,000 times the compute of an AI data center. And
Right.
then you try to wrap, and there's another point about inference versus training that people don't know. I think the training compute gets a lot more attention because it's sexier. We talk
Mhm.
about Dojo, we don't talk about hardware 4, hardware 5 as much.
Yeah.
Um, but I've seen estimates that inference compute, that most AI compute is inference compute. That maybe it's 52%. I think James Douma thought it was 95% of AI compute is inference
So
compute.
Chamath says it's gonna be 100 times, but then he's investing in Grok with a Q, so they make inference chips, and he says it'll be 100 times more. And then others are saying 20 times more. I've heard more of that number of James Douma, 20 times more.
Well, 20 times
Um,
more would be the 95%, roughly.
95%. Yeah, that's right. Yeah.
That's Dauma's number, and it makes sense. The problem is if you're trying to train these incredibly large and powerful models, then
Yeah.
you might be you still need a crazy amount of training. I think the issue is you're going to have a really large growth in training compute, but
Mhm.
you're going to have an even larger growth in inference compute.
Right. So lastly, I'll just say, $40,000 per chip of revenue, maybe $10,000 for Tesla. I said the user gets more because they have to pay for the energy, $25 per year. So that's my ballpark, but it could be $5,000 per year. I want to pay for energy. Tesla pays for coordination of a data center, splitting up the questions to get there. Hardware 3, hardware 4, just again, that the number of teraflops operations. So we can talk about tokens for a second, but I think we can skip over that. So I think there will be AI6, AI7. Okay, so let's get to, I think Google's twice as efficient on revenue, 15 times their cost, right? We saw that before from the Altimeter. So here is where I have 2026, 2027, and say, okay, here we're getting a chip per EV and a Tesla bot. So 3 million cars. So that would be $3.1 billion at $1,000 per chip. At $10,000
Wait,
per
wait, let me
chip,
just
that's
pause you. I think it's 2 chips in the car and 1 chip in the bot.
okay. So I will double that up. Yeah, the current hardware 4 has and hardware 3 have 2 chips because of redundancy,
Yeah.
because it's driving the car. So then there'd be 6.1 billion. But then eventually the bots and they cumulative. So 3 million cars and 5 million cars, but then it's cumulative that the cars from 2026 are still running and operating. Although I'm thinking that they may need to have a chip refresh every 4 years, that the chips, hardware 4, hardware 5, hardware 6, or AI5, AI6, AI7, that in order to keep up with NVIDIA improving until those things flatten out, you want to, while they're fast improving, you'd want to swap out the chip at a certain point in order
Elon talked
to get
about
more.
that. Elon talked about that at Autonomy Day. It is a 4-year cycle, but
Yeah.
they have 2 cycles running. So there's a new chip every 2 years.
Okay.
The process of developing a chip takes 4 years, but when you're 2 years into developing chip A, you start developing chip B.
Right.
So it's every 2 years a new chip comes out, not every 4.
Okay. Yeah.
That's the goal. I'm not saying they actually execute that way, but I think that's the goal.
Right. So if you can make the higher numbers of $5,000 a year per chip, then it's profitable within the first year. So you're making the profit, and then so then it goes to the total amount, which in 2029 you can get the $80 billion even at $1,000 per chip, and $400 billion at $5,000 per chip. But then the question of, is there demand for that, or do you have Tesla bring their big problems and would pay to have them solved, or XAI does. And then I'm going at 100 million bots per year from 2030 onwards, and 30 million cars per year, and then we have to double this up. So basically in the range of that 1 to 10 trillion once you get to in terms of like total numbers on this thing. And it's incremental revenue. So people have estimated large language models to maybe make $14 trillion in 2030. AI chips and data centers, $2 trillion in 2030. And then again, these are all like, predictions based on limited information of where we think it may go. So I had that rough extrapolation chart before, looking at compute and data increasing energy. And you discussed 100 megawatts for Grok, which Elon said we use that for Grok 3. Then if we get to 400 megawatts, that would be what I have for Grok 7, if you do that in 2025, and then you have more compute and other stuff like that. So the question of how much energy...
Are you saying that Grok 7 will be running on 400 megawatts in 2026?
Yeah, I had that ballpark estimated, but this was just me running forward, assuming more releases of it. Like I assumed Grok 3 would come out this year, but because Elon was talking about it, but maybe those numbers... those dates are wrong.
Yeah,
I made this projection.
I think we're going to see Grok 2 this year and Grok 3 next year, but
right. So then you'd have, slow up release. I start going to 1 a year, so that could mean Grok 4 2026, Grok 5 2027, and on. But then the energy may be different. We may be having 400 megawatts, and if Tesla can...
Well, let's be clear. I think NVIDIA is doing really, really well.
Yeah.
So for Tesla to come up with hardware that successfully competes with NVIDIA is really challenging. And I don't want to say they've given up on Dojo, but it doesn't seem like they're banking on Dojo in the future. It does seem like Elon's more confident about the inference hardware because Tesla's a leader in deploying real-world AI inference hardware.
Right.
And NVIDIA's chip, one of NVIDIA's challenges has been, it used to be they made graphical processing units, and then all right, this AI use case comes along, and we're making them to do graphics for video games, but we're also making them for this. And now NVIDIA is like, okay, we need to make GPUs for AI. But it's like, are you making them for training? Are you making them for compute? And is it the same mission? Do you need different hardware for different things? And, okay, they're using the H200 for inference. It may be very efficient for training, but it may not be as efficient for inference. And that's why the AI5 chip has an opportunity to inference at much lower cost. Now, Jensen Huang's not stupid. We've established that the NVIDIA team's really good. So they may start coming up with their own inference hardware soon too, but dedicated inference hardware. But right now they're just using H200s or whatever.
Right. So they're doing the H200s as inference. So they tuned it for inference. I think they tuned H200 for inference. So I think that they definitely planned to do inference chips, but there's also, their approach is limited by TSMC production, and also by HBM, high bandwidth memory.
And the other thing about the H200 is you can't put it in a car.
Right.
I mean, it's a monster. The
H200
is like a whole, like,
hundreds of pounds. It's a massive, like not an ordinary server. It's like it's huge. Like it's when you stack them together, it's like 2 tons or something like that. Like
they're impressive as hell, and they do a lot of compute, but like there's no variant of the latest NVIDIA chip that you can pop in a car,
right,
that I'm aware of.
Oh, they have special car hardware, which is the Orin and the Thor, which are their versions of hardware 3 and 4, which is used by the Chinese car makers, and the other LiDAR-based companies are using that
They don't have
drive system.
sufficient demand to really ramp that. They're not generating enough data to use it. It's that I don't know how much they've lined up that compute with the training compute. And that's why Tesla has this huge advantage, is because they've got the inference compute and they've got the training compute, and they're aligned and they have a very narrow goal. And the type of model you want for training on real world AI is probably different than the type of model you want for training on large language models.
Yes, yes. So I agree and also the reason Tesla chose to make their own hardware was because they were more attuned to it had to be more energy efficient, it had to
Yeah.
be more responsive. So they were specific to here's our problem. And then, they'll have one specific for their inference problem because they're, you integrated in terms of like
Yeah.
making the hardware, making software, and working the problem
Yeah,
and getting the data.
I almost think as efficient as the AI5 chip is probably going to be, I almost wonder if they can use like 1/10 of the chip to drive the car and have the other
Right.
9 doing other inference compute while it's driving. Like it wouldn't be limited to when it's not driving.
Mhm.
You know, the bot's a different use case. The bot may need more of the compute, but for the
Mhm.
cars, like we've all been saying, well, when they're not driving, they'll use it for that. It's like maybe they use it when they are driving.
Yeah, but that's only an additional 30% because it'll be, 30% of the time you'll be not driving. You don't need to have. I think there would be, liability concerns that, oh, you weren't using the full power and stuff like that. So by just saying it's fully dedicated to you while you're doing this thing, and then we uh,
Maybe.
yeah, yeah. So I think I'm a believer in super intelligence that we're not going to asymptote out on the large language models. That there's more there, although there are other kinds of AI for that.
Do you think
Um,
it's do you think we reach super intelligence just by adding more compute and data to the existing models? Or do you think they have to do stacked log curves and come up with new innovations to get there?
what all the people who are in it seem to be saying is that we get to super intelligence just with what we
Well, not Jan
mo,
LeCun.
mo,
Jan LeCun is not saying that.
yes, Yann LeCun does not, but Ilias is saying that we can get there. Other people can get there. When someone says, I tend, more optimistically, I tend to believe the people who say that they can get there, that they have figured out how to do it. Someone who doesn't know how to do it can say, okay, we can't get there, but it's the kind of thing where also that, Ilya delivered, OpenAI ChatGPT pushed it forward, and it was, I don't think Jan was the one on the Meta team that did the catching up for the Llama model per se. He did some work on it, and then someone else pushed it. So, but yeah, there are things in terms of like the hallucination, other stuff that needs to be resolved. So it can't be super intelligent in some things, but still have flaws and problems that are different than people have. Um, but getting to super intelligence on some things, like in the they have these Google proof tests where you can't look up on Google the answer to the on the internet search the answer to a problem. And so they have this test that they created in 2023, and PhDs and stuff were getting 30%. PhDs in that topic we get 60% or something like that. But the large language models have caught up. Like the Claude 3.5 Sonnet is at 60% on that more difficult test. So it's getting to the point where it's tough to test them. But it's a weird thing of like it can give really good answers to really hard problems and questions from people, whether it's programming and things like that. But you have to be smart enough to validate it, smart enough to ask the question, and smart enough to validate it in order to get it. So the system can do all this stuff, but it's like it's a reflection upon you, the questioner. It's like a genie in a bottle where it's like you're rubbing it and then you ask it some stuff. But it's like if you ask it something stupid, it doesn't give you a very good answer because you asked a stupid question, right? So how do we up level so that everyone can give it the good question? That goes to, some wrapper around it. So it there's so much there in terms of
Did
like
you
the entire
watch the
internet.
Did you watch
Yeah.
the interview with the Perplexity CEO talking to Lex Friedman? Because
Uh,
he talked about
yeah.
a lot of the stuff we're talking about. He talked about how we can't expect the AI, we can't expect humans to be better at prompting. We have to develop AI that's better at understanding bad prompts.
Right. Yeah. I've seen that, but that was something that was clear to me is that we have to make a better auto prompting, like a prompting enhancing system, and not with prompt enhancing of like make Nazis black or something silly, but like what Gemini did. But
I think it's almost like, are you sure you didn't want to ask this?
yeah, is you have this? Yeah. So, but that
I
involves
feel like I
maybe
think when I use Claude, after I ask a question, it shows me a list of it gives me an answer and it shows me a list of other questions I might want to ask, and it's pretty good.
right, right. So that
What you
being
really
able
wanted to
to
ask was this, didn't you?
right, and be able to guide it so that you can help you explore. So it goes to being a better Sherpa. That I need to say, by the way, here's all this other stuff. You didn't know that this existed or whatever, so yeah, so it has to improve that way. So in terms of like, but in terms of what's already there and how good it is, I think that, the great programmers can get it to do really good coding and programming. Great, smart people can make it ask a question the right way to get more out of it. But I think that was an issue even with GPT-3, where there was a usability gap. And they helped improve the usability gap, but it's still there. That the intelligence could be, super intelligence could be there. But it's just like, Albert Einstein walks in the room and then most people ask him dumb questions and can't get a good answer. You see interviews with Elon. Someone's
That's
talking to
exactly what
Elon.
I was thinking.
Yeah,
Like the people don't know how to prompt engineer Elon. They ask him the wrong questions. It's like pressing play and you get the, well, we need to accelerate the transition to sustainable energy answer, or
right,
he's he's got so many stock answers. It's like the challenge is how do you prompt engineer Elon so you
right,
get an answer he hasn't given before,
right,
right?
right. Or to give him, yeah,
Tim Dodd in his interview at Starbase
right,
in part one, he actually I've been dying for like 2 or 3 years to get an answer about the next generation rocket engine.
right.
He tweaked it a little. We didn't get a full answer, but we got
Yeah.
something.
Yeah. That basically you have to the LEAT engine, which was mentioned in the Walter
Yeah.
Isaacson book, which was supposed to be beyond Raptor. Elon basically said that it would be a redesign from scratch. We couldn't just tweak,
Yeah.
substantially tweaking, because they're changing the Raptor engines a lot. But he says that the Raptor,
I
yeah,
think that Raptor is performing so well
right,
that the need for elite became less. But I also think that long term, the way I what I'm hearing is that in the long term, the elite engine, which is 1337 for one of people who want to know, it's like 1337 upside down or something like that. That the elite, it's some nerd thing, that engine will actually be lower cost to manufacture and higher performance. So they'll
right,
get to it eventually. It's just that they're doing so well with Raptor. Like, well, let's get the rocket. They can get into orbit. They can bring the rockets back. Like, well, we don't need to worry about LEAP yet. That's like a down the road problem.
right. Yeah, but they're taking this next version of Raptor with no heat shield, with independent cooling on it, and they said that that will be the one they can mass manufacture. So
Right.
they've already made 200 of the previous Raptors, so that they have like 103 boosters sitting in the Mega Bay, um, which was on that interview
103
with Tim.
engines sitting on boosters in the Mega Bay, yes.
Right, and that, but if they go to mass production, he's talking about making 100 starships and boosters. I think starships and boosters, what saying 100 per year, which would mean roughly about 4,000 engines, Raptor engines per year. And then he said they make 10 times more, so like 40,000 per year in other locations, presumably scattered around Texas or something like that.
No, Florida and Texas are the two big ones.
Right, Florida and Texas. Yeah,
Building a manufacturing facility in Florida at Cape Canaveral. So
right. So it seems like the Raptor can scale to at least 4,000. I've seen them say that they have a engine factory that can make 4,000 engines. So whether they need to go to LEAP to get to 40,000, or whether they've done enough with manufacturability, because they did say one of the key things was even more manufacturable, lower cost, like you're saying, for the LEAP. But this Raptor one can also get there. So maybe it's enough there to make it 40,000 engines that they need to have. But they definitely would still want to have more efficiency, more payload, because each of their engines is doing that. But they're saying that the current one can get to Raptor. He's saying 330 tons of thrust, which would mean triple. You'd be tripling up from like 270 something like that to 330. So another 30% more.
The power of the rocket is triple the power of the Saturn V.
Triple the power of Saturn V. That's right. Right.
Oh,
So
this is, I think people, when we talk about numbers like that, I don't think it registers with people as much as my favorite explanation of what SpaceX is doing is before Falcon 9, it cost about $10,000 to put a kilogram in low Earth orbit. With Falcon 9, they've gotten that cost down to about $1,000, so it's a 10x improvement. With Starship, I think they have a very strong shot of getting to $50 a kilogram to low Earth orbit, which is another 20x improvement. I think Elon's gunning for $10 a kilogram, which is a 100x improvement and a 1000x on what existed before.
Yeah.
And then you say a cost of putting a package in orbit will be less than the cost of shipping a package across town.
Right.
It'll cost less to send a kilogram to orbit than it will be than the price of certainly, sending a kilogram from New York to Los Angeles.
Which is something we just
maybe from one side of the city to the other.
Which is something we discussed before, which was that when they get to those kind of costs, the only volume thing you can move is all packages. It's not just packages or satellites going to space, which will make mass produce, but that if I can move stuff at $10 per kilogram, then I'll put all air cargo out of business, that I'll be delivering them with rockets and to deliver things, because nothing else can move that much. And then it wouldn't be that bad in terms of the cost would be only upper stage of Starship. That would be the only thing I need to go point to point. I don't need to have the booster to go from Shanghai to New York or from wherever. I can go anywhere around the world with just the upper stage, which is 1/5 the cost. So even that $50 gets to the $10. If I get the $10, I get down to $2. And then the fuel I use is about comparable on long trips. International passenger travel using a rocket is actually not about the same as using a passenger plane, because I'm not pushing through atmosphere all the time. I'm like going up, coasting in very thin atmosphere, and then coming back down again. So the overall fuel usage would be comparable.
When we get excited about the future, if somebody actually delivers artificial superintelligence,
right,
or digital superintelligence or whatever, then we probably crack fusion.
Yeah.
And all of a sudden energy becomes borderline free.
Yeah.
And the cost of now SpaceX is manufacturing its propellant from CO2 in the atmosphere and water. And all of a sudden they're actually taking CO2 out of the atmosphere while powering spaceflight.
Right. And so in terms of that big future stuff, I have gone over the 40 some companies that are doing nuclear fusion. I have that on a separate thing. So if you want to discuss that or the molten salt fusion, another day. But so on the energy side, the AI demand for energy means that we will be, growing all this energy. So all this kind of like, we're going to do climate change. We're going to level off and just replace the oil and gas. And then we're going to do other stuff. Is that because we're going to need so much energy for AI and for human bots and everything like that the amount of energy, say over 20 years, they go up like 10 times. So, and then they'll go to an area of growth on that. It will have to be clean energy. We can't make it dirty because we just like cook ourselves. So it will be clean energy. So that's good news. It'll probably be solar mainly because we can't scale the other stuff up fast enough. It'll be solar and batteries. So that also goes to Megapack 3, all that stuff. And that goes to the advantage that Tesla has in that all these things that of like massive amount of energy, massive amount of compute goes to the manufacturing capability. And that Elon, with his factories, he solved those things. And he's the one who can, if you say, we're going to go to a world with 100 times more stuff. We're going to have 10 billion bots, 100 billion bots. We're going to have 10 times more energy. All those things are going to, we need innovations to do that. And the innovations that Elon's been working on for the last 5-10 years are ones that we're going to need for that. So that
Yeah.
again goes to his advantage and for
Did we finish your PowerPoint?
yes, we finished with PowerPoint. That was all done. So we don't need to go back to that.
No, I mean, I think when I just polled this and I'm like one of the few people who sees it. A massive use case for Optimus is deploying solar panels and building solar farms
Yes.
because it's repetitive and boring. I don't know if it's dangerous. It's dangerous on a roof, but
Yeah.
I could see building solar farms, whether it's on roofs or on the ground in particular with Optimus.
Right.
And how much do you lower the installation cost of building a solar farm if you have an Optimus doing the install work?
3 times. It's labor is about 60% of it. Of course, it depends on where you are, but ballpark, it's about 60% is the labor. So basically, you need to have that in order to, besides to get the cost advantage, just to properly scale up. That we need to make
Well, I
terawatts and
think we're going to
terawatts.
see. I think we're going to see Tesla and Elon. They own thousands of acres of land around the Austin area.
Yeah.
I think we may see a massive rollout of solar panels.
Right.
Um,
So you get about 200 kilowatts per acre. So if you have 25,000 acres, then that would be like 5 gigawatts that you would have from that thing. And there's always ways to, so concentrate the solar, do some more if you need to make more densification.
There's some interesting challenges there, and my gut hunch is they've already got plans, and we're going to see it in the next 6 months to a year. And Barry Glack and Lost Gerbil and James Catt and other, all the Elon haters will say Elon's doing it wrong because they know better than Elon.
Yeah, so that goes to the fact that he's doing he's doing 4D chess. Like I'm, using a lot of capability, so are you to try and like see, okay, that makes sense what he's doing, but stuff they haven't revealed to us that like he must be doing that, right? In order to get to, 10x energy, all kinds like the Megapack 3.
He wants to have 500 megawatts of AI data center in Austin, and I just saw like Sam Altman and Zuckerberg talking about how hard it is to go over 100 megawatts.
Right.
And like we're years away, and Elon's like, we're going to do that in 18 months. And they're going, okay, it's Elon, so they'll do it in 2.5 years or something. But how is he getting 500 megawatts of power?
Yeah.
On top of what Giga Texas already uses, which is probably a lot because it's manufacturing and they're, doing like all kinds of stuff. Like how are they and I think the only answer that makes sense is that they've got a plan to deploy massive solar.
Right. They have to be deploying massive solar. It's like I come to the same conclusion that they must make gigawatts of solar.
I did the numbers like a megapack farm. If you did a gigawatt megapack farm, it wouldn't be that expensive.
Mm-hmm.
You do a gigawatt megapack farm, and then you do, like basically 3,000 acres of solar or something like that.
Right. Right.
That to get your 500 megawatts.
Yeah.
To get to, and my gut hunch is that Elon's probably already like negotiated and bought a bunch of other land or has plans to buy a bunch of other land around there to just massively expand the solar.
Right.
It is an interesting idea. Are they going to do something to concentrate the solar? I don't think so.
Mm-hmm.
I haven't seen very many projects like that are successful.
Right.
But that it wouldn't be beyond the realm of what they might do.
Right. I think it's something that is in their back pocket, just like, air breathing rockets or something like that. You could do that, you get it at 5x, but you don't bother doing it until you actually have to. Just like, Elon's choosing to, in this talk with Tim Dodd, say, okay, we're going to do, this is a workable solution. We can optimize all kinds of ways, but we'll work on what works, what we need to now. Just like the 4680s, we make the batteries, make enough of them, and then work at making them better. So making a volume of it. So they need to make like the Megapack 3, which means they don't need to have substations, which is, like all these things that relate to the grid, substations, transformers, all that kind of stuff, is things that take the utilities, years and years to make, to make one facility or whatever. We made the grid over 100 years. So if we need to make 10 times more grid, if we do it the old way, it'll take us another 100 years just to double. So, or China goes it faster. They did double faster than that.
I just
But
want
it's
to
just,
apologize. I got like 3 hours of sleep last night. So if you see me yawning, I'm sorry.
yeah, no worries. We talked about a lot, and we've gone for like over an hour. So we can definitely follow up at another time, many other topics to discuss.
Yeah, I love talking to you, Brian. This is great stuff.
Thank you.
We should do a space on X also.
Yes, definitely.
I think we should plan a space on X maybe in the next few days.
Okay, that sounds good. Let me know what your schedule is, and then we'll do that. So thanks, everyone. And